During the Cold War, the US government was hell-bent on one-upping the commies in any way possible. In the process, they came up with a number of outlandish plans, such as that time they proposed literally nuking the moon, interestingly enough, a project a young Carl Sagan worked on and broke some laws with. More on this later. While it's probably for the best that that project didn't ultimately get carried out, there is another that went into history's dustbin that would have been amazing if implemented: the U.S. Army's plan to build a massive military and research installation on the moon. This is the story of Project Horizon, along with a lot of other interesting related tidbits along the way, from what a nuclear explosion would look like on the moon and whether a nuke would actually be a terribly effective weapon in space, to the guns designed for astronauts, to the rather humorous first thing Neil Armstrong and Buzz Aldrin did on the surface of the moon, to the dick pic that exists in the so-called first museum on the moon and the famous artist who drew it, to the fascinating story of the man who successfully sold the moon and apparently made a fortune in the process. This is going to be a good one, and to talk about all of this today, we're trying something different by welcoming in our resident genius, engineer, author of the scripts for over 500 videos we have here, the owner of the phenomenal channel, Our Own Devices, the Professor Gilles Messier. So let's dive into it all, shall we? To begin with, the Project Horizon report notes, the Soviet Union in propaganda broadcasts has announced that the 50th anniversary of the present government, 1967, will be celebrated by Soviet citizens on the moon. So at this point, the U.S. National Space Policy Intelligence thought this was a little optimistic, but still that the Soviets could probably do it within a year or two of that. And as you might expect, the military deemed this a potential disaster for the United States for several reasons. First, if the Soviets go to the moon first, they could potentially build their own military space station there, which could be used for a variety of secret projects, and including spying on the U.S. In the extreme, they could potentially launch nuclear attacks from the moon with impunity. Number two, if the Soviets landed on the moon first, they could try to claim the entire moon for themselves. And and then if the U.S. could try to go there, it wouldn't be it could be considered sort of invading enemy territory. So the U.S. would be completely barred from the moon, which is just crazy to think about.
And that was interesting that they announced that in 1967, because that was the exact year that the Outer Space Treaty was signed that would have stopped that sort of thing.
Yeah. And aside on that, speaking of the ownership of the moon, back in the 1980s, there was a guy called Dennis Hope who claimed he owned the moon. Because of that, as you said, the 1967 Outer Space Treaty, he said there's a loophole in it that allowed him to own the moon. And then he ended up making quite a lot of money and a career for himself. I think pretty much in the last few decades, that's what he's done for a living, is sell portions of the moon, Mars, and whatnot, because of this supposed loophole. We're going to get to that more in the bonus facts later.
Although really, you don't even need a loophole like that. People have been selling stars for ages. People have been selling, the established titles, plot of land in Scotland. If nobody's actually going to go there and do anything, you can sell whatever you want.
At least the Scottish one, at least they were planting trees and stuff.
Yes.
But he's just making money on it. He also sold mineral rights and things like that. And his justification and stuff, he's pretty funny. We'll get into it later, but there's even a thing on his website that is a guide to potentially spotting fraud. And so he definitely has a good sense of humor. But in any event, beyond the practical downsides of having the Soviets be the first on the moon, this would also see them not just claiming the international prestige of an accomplishment like landing and building a facility on the moon, but also countless other discoveries and advancements after, which the U.S. at this point was obviously feeling quite behind on, because the Soviets had the first Earth orbiting satellite, the first animal in space, first spacecraft to reach the moon, first spacecraft to photograph the far side of the moon, first man in space, first woman in space, and the first spacewalk. They were seemingly dominating. But
that was a bit of a myth, because they had a whole bunch of mistakes, a whole bunch of mishaps, but of course they had a huge propaganda machine, a huge secrecy machine running to deny the world knowledge of any of that. So yeah. And especially with their moon landing program, in 1967, they were 2 years away from actually testing their N1 moon rocket, which blew up all 4 times they tried to launch it.
Yeah. Well, and also there was one you did a while ago on if there was anyone before the supposed official first man to orbit and stuff like that. Yeah, what was
And
the consensus there?
the answer is no. There is absolutely no evidence, and most of the figures that people cite were killed in related accidents. In there was one, he was killed in a, this is actually, I believe, after Gagarin. He was killed in a training accident in a hyperbaric chamber where it caught fire. Others, they were jumping from high altitude balloons, and one cracked his helmet. Some were just expelled for bad behavior, and they were erased from photographs. Like, there's a famous photograph taken at Sochi of the Vanguard 6, I believe it was. They were basically the Mercury 7 of the Soviet Union. And one of them was erased because, well, he got drunk. He got into an altercation with some military guards, and they kicked him out of the program and erased his photo. And that became the fodder for conspiracy theories. They said, oh, he launched before Gagarin and he died, and so they erased him from history. It's like, no, he got drunk and started a fight, and he refused to apologize.
Yeah, that's interesting because also, like, before that you had like Stalin who was erasing people constantly. Even like there's famous guy who, one of his like top right hand men, and he just, like, for, I don't remember the reason, but they had a falling out, and then he got killed. And then you see there's a lot of really famous photos of Stalin where if you look at one version he's there, and the other, they did a really good job pre-Photoshop of just, he's not in that photo anymore.
Oh yeah, and that's where it comes from. Like, there was a pretext for that of people who were actually liquidated, who were erased from history. But in that case, it was less. He did die. He committed suicide later on. That particular cosmonaut. But it wasn't that case. It was just like, well, we don't want to admit that this guy was ever in the cosmonaut corps at all because he wasn't cosmonaut material. And even even Gagarin got into a whole bunch of trouble after his space flight, but they couldn't do anything about it because he was the national hero. They had to hush all of that up. Like, again, I think it was around Sochi. It was one of those resort towns where he went, chasing skirts, and he fell off a balcony and busted his head open, and they had to cover that up.
Well, that, I think, also led to like all the conspiracy theories that his death was not an accident.
Yeah, which it almost certainly was. Like, we still don't know what was going on, but they were flying a very old jet on a day with very bad weather. All sorts of things that could have happened.
But anyway, yeah, so the U.S., obviously all their stuff was in the public. The Soviets like to just, show their triumphs and none of their failures. But anyway, going back to the Soviets on the moon, the Soviets obviously might do none of these things the U.S. were worried about. They might not claim the moon. They might not, build bases. But as noted in the Project Horizon report,
clearly, the U.S. would not be in a position to exercise an option between peaceful and military applications unless we are first. In short, the establishment of the initial lunar outpost is the first definitive step in exercising our options.
So the threat of the Soviets first simply would not stand. U.S. like to be first. So as President Lyndon B. Johnson would famously state in 1964, I do not believe that this generation of Americans is willing to resign itself to going to bed each night by the light of a communist moon. Thus, long before Kennedy would make his famous May 25th, 1961 declaration before Congress that the U.S. should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth, the military brass in the U.S. were dead set on not just man stepping foot on the moon, but building a military installation there and sticking around permanently, which would have been so cool. Like, and you think about all the advancements and things would have been made, like just a base like that could have done. Which we'll get into some of it, some of the things they had in mind for the future. And it was so wildly optimistic about where we were going in space and like in the immediate future. It was amazing.
Yeah, and I don't think a lot of it would have been too outlandish. It was just a budgetary issue. Like they had the hardware. There were a lot of things that were planned. It was called the Apollo Applications Program, where they were going to build off of the same hardware that they had during Apollo, but about the only thing they ended up building with that was Skylab.
Well, and it would have been, like so much of the cost was in the development in the first place, was once they had it. Like it could have been so many awesome things. And you look at, we're going to get into some of the budget things later of how much was actually spent and how much this project was meant to spend. And it was just a drop in the bucket, like compared to what they were spending on other things.
Although that said, they probably would have had to come up with different hardware, because you look at the Saturn V, that was developed for one mission. Like, yes, they could have adapted it, but it was one mission. It was, land 2 people on the moon for a couple of days, bring them back. And probably not the most efficient way of, it was the most efficient way of doing it, but the most efficient way of doing it quickly. It was, we need to get this done by the end of the decade, and here is the most efficient way of doing that. So yeah, they probably would have had to develop something a little bit different. One of the wackier things that they tried to come up with was Sea Dragon. You ever heard of this one?
No, I have not heard of that one.
So Sea Dragon was even bigger than Saturn V, and it was so called because you would launch it from the water. It was part of a design philosophy called the Big Dumb Booster, where the idea is you build the simplest, dirt cheapest rocket you can. You make it really big so that even if the thing is not 100% efficient, if it's not the most elegant design, you can still get a whole bunch of payload into space economically. And yeah, this thing would be floated out like a barge into the middle of the ocean, and then the bottom compartment would flood, it would go vertically, and then it would launch out of the ocean. And it had just pressure fed engines and all these things. It was made out of steel rather than aluminum or anything more complicated than that. Yeah, it was a big dumb booster. And actually, going, another sort of pop culture thing, if viewers are interested in this sort of thing, Apple's show For All Mankind covers a lot of this stuff, and it's so fantastic. It's one of those shows that was written for nerds who know all of their early NASA history, and they show forming a base on the moon using Apollo hardware, and they show the Sea Dragon being used, and they really did their research. And a lot of the stuff that they show is stuff that existed or stuff that was in development and they never got a chance to use. So yeah, so it's one of my favorite shows. It's fantastic.
Yeah, I'd not heard of that one. That's pretty cool.
Yeah, it's the premise is that the Soviets do land on the moon first, and then the space race takes a completely different tack, and it's alternate history at its best. It's a great show. I'd highly recommend it.
Yeah, because that probably would have been a good thing for the advancements, because if the Soviets made it to the moon first, the U.S. you'd think would just double down on everything, just like, well, we're going to Mars or something,
Yeah, absolutely.
Yeah. But going back to Kennedy, though, just also wanted to mention that a lot of people don't know Kennedy really wanted the Soviets and the U.S. to join together in all of this. And Kennedy would state in his his Rice speech on the matter, I say that space can be explored and mastered without feeding the fires of war, without repeating the mistakes that man has made in extending his writ around the globe of ours. There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to all of us. Its conquest deserves the best of all mankind, and its opportunity for peaceful cooperation may never come again. And you think, like, how different everything would have been if they would work together. Like, even the Cold War, you'd think it probably would have cooled it down somewhat, working together on such a cool thing.
Maybe, or it could have been a smokescreen. I talk about this in my video on the NS Savannah, the nuclear ship that Eisenhower started this whole Atoms for Peace project to promote peaceful uses of nuclear power, but in reality he was building a big nuclear arsenal behind the scenes, and he needed some way to cover that up. So yeah, it's interesting, but yeah, it's interesting that nobody talks about that part of Kennedy's speech, but I guess it's not nearly as quotable or soundbiteable as we choose to go to the moon.
And it's also like it dovetails in, though, you almost think, Kennedy may well have meant it, just because so much of the other stuff he did, which obviously rubbed the military the wrong way and also gave rise to a lot of conspiracies that, there was more to his assassination than other things, because he was always considered soft on communism and soft, he always, always trying to bridge that gap a little bit, which, yeah. But yeah, apparently Khrushchev, he said no, obviously. But according to his son, his father actually did consider it, and he later did sort of change his mind on it. But the Kennedy assassination sort of put an end to that, because he didn't trust the subsequent president the same. But said his son, he thought that if the Americans wanted to get our technology and create defenses against it, they would do that anyway. So maybe we could get technology in the bargain that would be better for us. So he was actually considering it, but yeah,
that, ladies and gentlemen, is realpolitik.
Yeah, but yeah, that sort of put an end to it with the assassination. But yeah, the Soviets obviously did have their own version of the moon base too that they were working on. How do you pronounce that?
Zvezda.
Okay,
yeah.
But yeah, theirs was cool because they actually were considering making it on a mobile platform, which would be super cool. Just go around, but.
I mean,
But yeah,
easier to do on the moon when you have 1/6 gravity. A lot of things are much easier to do.
Yeah,
Although I
going back
can't
to Project
imagine
Horizon.
keeping. Sorry to interrupt. I can't
No, go
imagine
ahead.
if you have a mobile platform keeping the regolith, the lunar dust, out of that thing.
Oh yeah.
Like that was a huge problem that the Apollo astronauts had, was because the regolith is formed by meteorite impacts, so it's sharp. It's these razor sharp grains of sand, these little needles, and it got into everything and it wore everything down. Like it tore their spacesuits to shreds after only a couple of hours on the lunar surface, and it got into everything. So apparently the moon smells like gunpowder. Yeah. So when they got back on board the LEM and they took off their spacesuits, it smells like burnt gunpowder in here. So that's what the moon smells like, apparently. But yeah, this was a huge problem that they had, and it's still a problem today with with the Artemis program. They're trying to figure out ways of getting around this dust because it just destroys everything. So I can't imagine having this big mobile platform that you intend to move around, more than a couple of times. The bearings on that would probably get shredded.
There's also the funny thing about that gunpowder smell is some of the astronauts had the little hay fever basically from the moon dust,
Yeah.
but they often didn't want to talk about it.
Yeah, they were allergic to it. Yeah.
Yeah.
So
it's crazy.
Yeah, all sorts of unexpected problems when you get to an environment like that.
So on March of 1959, going back to Project Horizon, the chief of Army Ordnance, Major General John Hinrichs, was tasked by Chief Research and Development Lieutenant General Arthur G. Trudeau with developing a detailed plan on what was needed to make their moon, base happen, and a strict guideline they wanted. It had to be anything they use had to already be something that they already had the technology for, was already made, or it was very close to being completed. So to keep it cheap and everything and quick, it had to be basically something that they could do with existing technologies for the most part.
Just to jump in there on Arthur Trudeau, so that's a familiar name to me because I do a lot of research on Gerald Bull, who was the Canadian scientist who tried to reach space using giant guns. He built a giant gun for Iraq and he was assassinated. For a big story, but Trudeau was one of his point men, one of his main contacts in the US Army, because at the time, the Army and the Navy were battling hard to stay relevant in space because all space exploration was being concentrated in NASA and anything military was being given to the Air Force. But the Navy and the Army both wanted, they wanted a foothold in space. They were latching themselves onto any project that they could to stay relevant. So Project HARP, which was Gerald Bull's attempt to send little satellites into space using a giant gun, Trudeau latched onto that because okay, well, this is something that the Army can do to stay relevant in the space race. And indeed, the Navy was very involved early on. They were the ones who developed Vanguard, which was the first rocket that they used to attempt to send an American satellite into orbit. It didn't go so well. It blew up on the pad on national television, quite infamously, leading to my fantastic nicknames like Flop Nick or Kaput Nick. My favorite is the East Germans when they finally launched Vanguard, the second attempt, and finally got it into orbit. And also Explorer 1, when the Americans finally got into orbit, the East Germans called it Spätnik, which Spät means late.
Nice. So they gathered basically all, so as Major General John B. Madera said, we grabbed every specialist we could get our hands on in the Army, and the resulting report that, all their recommendations on how they would do everything and with what technologies was published on June the 9th, 1959, and went into great detail on every little thing, right down to, how they're going to scrub the carbon dioxide. So what did they come up with? To begin with, it was deemed that the transport side could be accomplished using nothing more than Saturn I and Saturn II rockets. Specifically, they had in mind 61 Saturn Is and 88 Saturn IIs would transport about 500,000 pounds of cargo to the moon. And in an alternate, so that was going to be a direct to the moon, and you launch, you go right to the moon. But they also had a second option that they proposed, which was to develop a space station in high Earth orbit, and so you could get a lot more. So if they're going direct to the moon, they could only do about 6,000 pounds or 2,700 kilograms per shot. But if they just had to go to high Earth orbit, then they could do quite a bit more, and then they would have to develop another thing that goes from the space station to the moon, but it could just transport back and forth.
Which is sort of like the Lunar Gateway project that they're coming up with today. It would be very similar to that. But yeah, this is another. We just published this video on how they learned to go to the moon. Yeah, there were basically three methods. There was direct descent, And they were actually planning on building a rocket even bigger than the Saturn V, if you can believe it. It was called the Nova, to launch this massive spacecraft that had the capsule at the top and then your your service module and then landing legs on it. So the thing would go straight there. Earth orbit rendezvous, which was with the space station. Werner von Braun was very keen on that because he wanted to build a space station anyway, so he was sort of piggybacking on that. But then they found that trying to coordinate dozens of launches and assemble this whole thing in orbit just was not feasible. And so that's why they finally went to Lunar Orbit Rendezvous, which was you have a very tiny, lightweight lander attached to your main command service module. You send that to the moon, and then it goes down and it comes back up, and then you go back. And yeah, there was an engineer named John Hubble who basically went over the heads of everybody at NASA because he believed in this idea, and everybody was against him. And they finally read this report and said, yeah, you know what? You're right. This actually makes a lot of sense.
I thought it was interesting too, the faith that they had on because the engines on the LEM they couldn't test fire it because of the specific design.
Yeah.
So it had to this is the first time we're going to try this engine on the moon. If it fails, I'm sorry, guys.
But on the other hand, they made it as foolproof as possible. It was a hypergolic engine, so it was nitrogen tetroxide and an asymmetric dimethyl hydrazine. So that's they're hypergolic. Then when they mix together, they ignite. So all you had to do was open a pair of valves. You didn't need an igniter. You didn't need anything. It was you open a pair of valves. It either works or it doesn't. So I think it was an example of managed risk where they're like, we've made this as foolproof and as guaranteed to work as possible. Yes, we can't do a test firing beforehand, but it's almost guaranteed to work. So yeah, managed risk, which is something.
What could go wrong?
Many things could go wrong. I mean, hypergolic fuels. Well, again, another one you recently published on the Damascus incident where a Titan II missile blew up in its silo. And yeah, it used the same fuels as the LEM. And somebody dropped a socket wrench and it bounced off the side of the silo and punched through the fuel tank. And a couple of hours later, up it goes.
Yeah. So whichever method they ended up were planning to do, they were going to have just a pair of, so they would first start with a pair of astronauts. They would go to inspect everything once it was on the moon, see if seen anything. And they were planning on doing a 1 to 3 month stay for these astronauts while they looked over everything, see if there's anything, replacements that need sent or whatever. And then after this, they planned on having a construction crew go that would actually be the ones to put it all together. And it was kind of cool. They, unlike the Soviets who, were thinking of like a mobile or even on the surface, they were going to use, a specially designed bulldozer type, backhoe type thing, plus explosives to create trenches on the moon and then put their station there, then bury it. So it gives some protection from, they were also worried about protections from attack, not just meteorites, which is just funny in the military. But we're going to get into there too. They had a lot of stuff. They were thinking of defensive, like arming the astronauts and things, which is, I don't know, it's just funny to think about. So they also, as for power, they were going to do redundant nuclear reactors plus potential for solar power for a little further redundancy, just in case. Do some scientific laboratories, which they were going to do, also going to do a rec room, hospital unit, housing quarters, a section made for growing food sustainably. And then in the meantime, they were going to do augment with frozen and dehydrated foods. Also extensive radio equipment. And this is also their optimism of the radio equipment, not just to communicate back to Earth, but to form like a communications hub, both for the U.S. military on Earth, which is, it can't be touched by the enemy, or not easily. And then also for relay for deep space communications, which they were thinking, the optimism there. It's great. It's too bad some of that didn't come to be. But they also proposed a moon truck capable of transporting things around, as well as bomb shelters. And they were going to use the water, oxygen, and hydrogen from ice on the moon to do fuel and obviously for their own needs. And there's also kind of thing about those rockets, if you really think about it, are just really advanced water rockets in some respects. But yeah, and being a military installation, they were going to have 12 astronauts at any time, and they were going to equip them to defend themselves against attack from all the enemies on the moon. So they had personal sidearms, a space gun basically, which was more or less their original design, everything more of like a modified shotgun that could be used by someone in a bulky spacesuit, which we're going to get into the spacesuit a little later. It's they were thinking more of like an Iron Man rather than fabric, like NASA went with. And they also were going to give them Claymore-like devices to be stationed around the base's perimeter, and also they could be fired remotely and just, a hail of buckshot at high speeds at everyone with incredible range because of the low gravity. And yes,
when you want to reach out and kill someone, but they're miles and miles and miles away.
It's just funny because also, I mean, what are they thinking? Like, invading troops are going to land far away, and then they're just going to like lope along in their spacesuits, and
And again, they cover this in For All Mankind. They actually have a scene where they've got one of these. It was a modified version of the LEM, which was meant for long distance transport, where these Marines are actually in their spacesuits on the back of this LEM going towards the Russian base, and they all start humming Ride of the Valkyries. It's great.
And I just think, if you're a human, I think just human psychology, you're a bunch of astronauts sitting on the moon on either side. It's so dangerous already. Aren't you really? Come on, let's just get over it and let's just all get together. Like, it's a hard time imagining them just being like, our first priority is to blow you guys up, but I guess, if that's their mission, and especially if you're using it as a radio relay, maybe they have some incentive. But then why not just launch a missile at it? Like, that's rather than send humans for the job.
If you want to capture their technology, I guess, like if you want to eliminate the cosmonauts or astronauts, depending on what side you're talking about, and inspect their base, and you don't want to destroy it.
But you also always hear like the people that go to space, they look back at Earth and they're just like, like, what? This is silly, guys. What are we even doing here? Like, it gives perspective, and I just wonder how much that would affect people actually trying to war in space. Yeah, so also for people wondering, yes, the regular firearms would indeed work in outer space. The propellant powder has its own source of oxygen and everything. So you don't really have to modify the design too much. The one thing which you mentioned, this is from one of yours, I'm about, I don't know, probably half of this whole thing is from one of yours, maybe even more. But similarly, the grease for lubricating oil on the guns, which you've forgotten more about, like firearms, than I've ever known. So did you want to explain what's going on there?
Yeah, well, the grease would either freeze or it would evaporate away in the vacuum of space. You can't use regular lubricants. I think you can use something like graphite or lithium grease, which is what you use for like locks in the winter. Being up from the middle of Canada, we're quite familiar with lubricants failing in the winter. Or you would use not at all. So during the Nazi invasion of the Soviet Union, Operation Barbarossa, they quickly found that the lubricants in their firearms would freeze in the Russian winter. So they ended up just dunking their firearms in gasoline just to dissolve away all the grease, and they would run them dry. And it didn't last very long, but at least they worked, and they could bring up new ones. So, although one thing I do wonder, and it's something that'd be interesting to look into, is whether the shape of the bullets would need to be changed for use in a vacuum, because when you create bullets for use underwater, and the Soviets did this, they had a couple of underwater rifles for frogmen. They had to create a new bullet shape. It was a long dart that was hydrodynamically stabilized, because a bullet that's meant for air quickly loses energy, and it quickly becomes unstable, and it goes through a denser medium like water. So if you're firing a bullet that does have some aerodynamic stabilization capability designed into it, like a lot of it is gyroscopic, and you're firing it in a vacuum, I'm wondering if it would start to precess and start to tumble, and it would start keyholing a lot sooner. Yes, it would go farther, but it would be tumbling most of the way there. I'm not quite sure, but I do know that bullets are designed with some aerodynamic stability in mind, not just gyroscopic. And you have to you have to adjust them for different media. So I'm wondering if you would have to create a different bullet design to work in a vacuum, at least at long ranges.
Yeah, that's interesting. And we're going to get into like some of the weapons and stuff, and like the nuke and stuff, and how effective it would actually be on the moon, because we think of like a nuke as like super, on the Earth it's like the ultimate weapon, but like in space, we're going to get into it, but like I feel like it's actually a really inefficient weapon. It doesn't really, it's not going to have the effect that you're going to have here. So you'd almost like a traditional shotgun or something would almost be more effective, which is weird to think about, but we'll get into that. But also, the problem with one of the things with the finish that they would have to change of the weapons is the dark finish on typical guns in here and stuff, it would just absorb the solar radiation and potentially like ignite the stuff or cook off. And so, yeah, not good. But they could just do reflective white metallic coatings, or like you said, the shiny ray guns in like futuristic movies where it reflects rather than actually had some practical purpose. And then, of course, firing any weapon in space, you're going to have the recoil action is just, if you're not, thoroughly grounded or affixed to the ground or what, you're going to have some issues. So you're going to have to need, like maneuvering thrusters or something to counteract the recoil, which also on that, even though like in space, it would be great. Like we did one a while ago on what would happen. When you see in movies a lot, people get shot and then they like go flying backwards, and it's just like, no, like, because if they went flying backwards, the person shooting the gun, unless they were really stabilized, they're going to go flying backwards. There's just not enough force for that. But in space, total different thing. You're gonna have trouble staying stable when you're firing. So,
although really, like for something to be lethal in space, for a firearm to be lethal, it doesn't, like, if you're just puncturing somebody's spacesuit, you could bring a 22. You could bring something that has a ridiculously low amount of recoil, or even, you could have basically an air gun. You could hook it up to the oxygen feed and just fire pellets at people or something like that. You could bring something that has almost no recoil. It would still be very deadly, because if you puncture your suit a couple of times and you can't get to help, you're screwed.
Going back to like nuclear weapons, so you'd think so, and they actually had a plan to equip the astronauts with nukes, and handheld nukes no less, based on the Davy Crockett nuclear gun, which for those who don't know it's a 76-pound nuclear round from an M28 or M29 smoothbore recoilless gun, and it used a variant of the W54 warhead placed in an M388 round, which could produce 10 or 20 ton yields, which is just crazy. It's not like a handheld weapon, but kind of close, as close as we can get to an extent, but it would shoot on Earth anyway. 1.25 miles was its range, which, as the person firing it, just doesn't seem safe, but it was, as long as the wind was, not going the wrong way. Never used on Earth, but they thought it could be used on the moon effectively, and it's way lighter on the moon. Obviously, it would be light enough. I think it was 30 or 40 pound equivalents or whatever. Which can you just imagine, like an astronaut, because a single astronaut on the moon could carry one and just like say hello to my little friend. It's a big old nuke thing. But it was an interesting weapon. Oh, there we go. It's 100 of the Davy Crockett guns were deployed, and they could fire it in about one round every 2.5 minutes on Earth. They were trained. And I thought it was interesting on the trigger mechanism. So it had a timer to arm the thing, and then it would shoot. And then it was designed, obviously you would try to get it. It had a radar trigger to actually, do the thing over your target or whatever. It's, above ground detonation. But if it didn't, if it was a dud, they instructed them to go recover the round if it didn't actually go off. But there was no way to, disable it at that point. So you were just trusting that the radar thing that you set, and it had a high or low trigger, just didn't work. Like it went off, but it didn't work, rather than that it just didn't trigger. And you're going to be handling this thing that could just go off, but there was no way to disable it. I just feel like there's not a lot of soldiers who would have actually gone to recover had they actually fired them.
No, and they actually had a hand-portable version of the same warhead. It was called SADM, the Special Atomic Demolition Munition. Probably the only real suitcase nuke that's ever been developed, at least that we know of. And yeah, it was even crazier, where you had a 2-man parachute team. You would parachute into enemy territory carrying this thing in a satchel. And you would put it up against a dam or a radio station or whatever you wanted to blow up, and set the timer and run somewhere. But what's incredible is, we talk about how precarious that arming system would be. The history of nuclear weapons mishap shows us how good, strangely enough, nuclear weapons safety systems are, because there are tons of incidents where they've gone through their entire arming sequence up until there's like one switch. I think it was the Goldsboro crash. There was a Strategic Air Command bomber that broke up in midair, and the bomb fell to the ground, and it went through all of its arming sequences, and then it buried itself in a farmer's field. And the only thing that stopped it from detonating was one switch in the cockpit of the aircraft that had been turned to safe. There's one tiny switch, and it did not close, and that stopped, I think it was South Carolina, from becoming a radioactive wasteland. And this happens again and again, where you have nuclear weapons that they cook off, like where there's a plane crash and the conventional explosives aboard the weapon detonate, but because they're designed to only be triggered in a very specific way, all of the detonators have to go off in a particular sequence in this particular frame of time. It scatters plutonium everywhere, and you've got a massive cleanup on your hands, but no nuclear detonation happens. So, yeah, nuclear weapons are weird. They're extremely dangerous, but at the same time, they've made them incredibly safe. And that's one of those. They have a term for that in nuclear weapons policy. They call it always never, which is that a nuclear weapon should always work when you need it to, because otherwise it's not much of a deterrent. Because if your enemy knows that your arsenal doesn't work, well, then where's the deterrence in that? But also, they should never go off when you don't want them to. And so nuclear weapons design is all about squaring that particularly weird circle.
So yeah, and then, so speaking of on the moon, so on Earth, when the Davy Crockett it had one of the things beyond the little blast zone was also the radiation, the ionizing radiation zone, which was an effective way, unless the wind was facing the wrong way, and then it's, coming to your troops, and then you're just going to kill your own people too. But on the moon, you think how effective, so to get into we're going to now jump into how effective would this actually be on the moon? And so you think about that, it would still have those, ionizing debris that's being blasted around. But you think the spacesuits and things are probably already pretty, resilient to ionizing radiation just by their nature. To some respects, they have to build that in to an extent. So it'd probably be less effective. You'd still have that area, though, but less effective. So that's one thing. I mean, would you agree with that assessment? Or
yeah, you have. Well, yes and no. Spacesuits are somewhat hardened against ionizing radiation because you do have a lot more cosmic radiation without the atmosphere in the way. But astronauts still have a lifetime dose that they're allowed to accumulate. They typically deal with radiation not really through shielding, because shielding is heavy, but through limitation of overall exposure. So yes, but a nuclear weapon produces a big neutron blast, and neutrons are really hard to block. And so at least at close ranges, if you got a full blast of neutron radiation from even a small nuclear weapon, you're dead. I mean, that's what happened to native of my city, Winnipeg, Louis Slotin, who was the Manhattan Project physicist who did Tickling the Dragon's Tail, where he had two hemispheres of plutonium and he was putting them together with a screwdriver, and the screwdriver slipped and they went together. And he got a big blast of neutron radiation. I think it was a week or two afterwards, he died in a horrible agony. And there's really not much you can do about that. And then you would have the fragments of the bomb itself, basically a plasma expanding out through the vacuum. And if you got hit with that, that could do a lot of damage. But you're probably about to say, there's no atmosphere, so you don't have that superheated air to form the shockwave. The material you have to produce a shockwave is limited to the bomb and maybe a little bit of lunar regolith that gets sucked into it and blasted outwards.
Well, and that's why I was thinking it would be almost want to pack it with a ton of other material a little bit, almost like a hand grenade type of thing, but giant, as much as you can to maximize the effect.
Yeah, and that would actually probably make the weapon even more efficient, because in nuclear weapons, around the core, you have something called a tamper, which is usually a hollow sphere of uranium, depleted uranium sometimes, or lead in some cases. And what it does is that when the explosives start squeezing in on the tamper and the core, that collapsing sphere has momentum. And you need to reverse that momentum in order to blow it back out again. And so it allows the core, the pit is what they call it in nuclear weapons design, to be compressed for longer and release more of its energy before it has enough momentum to start expanding the tamper back out. So if you built a really big tamper, you had a really heavy case around the bomb, a lot more of it could actually be converted into energy before the thing actually blew apart.
The US actually but then I was kind of wondering what, so on Earth. You blast it, and if it's an above ground one, you're going to get this like mushroom cloud formation everybody is familiar with. But what would it look like on the moon? And that's where the U.S. military actually had a Project A119 labeled a study of lunar research flights developed by the U.S. Air Force in the 1950s. And so they wanted to shoot a nuke at the moon, pretty much just to shoot a nuke at the moon and get it there, and everybody could see we blew something up on the moon. Like you could see we got to the moon. Basically, it was just kind of like it seemed like an easier thing to do, just to show, hey, we can keep up with the Soviets type of thing. Like we can put something on the moon, sort of.
It would have been fantastic to be an engineer in the 1950s and 60s, because you could just walk up to whoever had the money and say, hey, I've got this insane idea that nobody in their right mind would ever go for in a million years. And, the bureaucrats would be like, does it fight communism? Yes.
Yeah.
Here is all the money.
Yeah, so whatever you need.
We want to build a giant spacecraft that travels through space by throwing nukes out the back of Project Orion. This is a real thing. We want to build a giant cruise missile powered by an unshielded nuclear reactor that has 50 hydrogen bombs that just goes around the Atlantic until you need it to go to the Soviet Union and screw some shit up. Okay, here's all the money. It would have been great. What a time to be alive.
Yeah, totally. But yeah, so they also, because the purpose was they needed to be able to see it. Like you had to be able to, you wanted everyone to see this blast on the moon. So they hired actually a young Carl Sagan to see how would the cloud actually expand? Like what would we see? Basically, would it be clearly visible from Earth, and how? And of course, they wanted to do it on sort of like the borderline between the light and the dark spot to do maximal visibility against the blackness of space.
That line has an awesome name. It's called the Terminator.
Oh yeah, nice. What would that look like? And I don't know. I was kind of looking around, and there's a lot of speculation on what it would be. And I was looking at we'll just go briefly into like what actually causes that mushroom cloud formation, and it's the Rayleigh-Taylor instability, and by extension the convection that is happening. So in a nutshell, we have a ball of burning hot gas that's accelerated outward in all directions. But since the burning ball of accelerated gases is hotter and therefore less dense than the surrounding air, it will begin to rise, in the case of a nuclear explosion, really super rapidly. And this ultimately forms the mushroom cap. And as to why, as the ball rises, it'll leave behind air that it's heated, creating a chimney-like effect that draws in any smoke and gases on the outer edge of the chimney. And visually, this forms the stalk of the mushroom. And the perception that the mushroom cap is actually curling downward and around is actually from the difference in temperature at the center of the cap and the outside. So to visualize it here, the center is hotter and therefore will rise faster, leaving the slower outer edges to be caught up in the steep convection. And once that cloud reaches a certain point in our atmosphere where the density of the gas cloud is at the same as the density of the surrounding area, it'll spread out, and hence we get this nice cap. So I should also mention the resulting cloud ring around it, which is just from the low pressure area that's created. It kind of drops the temperature below the dew point, creates a nice little thing similar to what are they called? Contrails, or what did people? Is that the actual official name? Or is that just the conspiracy theory?
No. Chemtrails are the conspiracy thing. No, they're actually called. They're called contrails. Yeah.
Yeah. But that's the same thing where you get like the jet. You get some particulate matter can also form it, obviously, because it needs something to
it needs a nucleation site to form.
But then some of it is just that drop in temperature, which creates that nice thing, which you can actually tell some stuff about. I'm not going to get into it, but like when you get like a pilot's license, you learn a lot about the weather and stuff. You can tell actually a lot about the weather from these cloud formations, and if these high jets are creating those things, you can tell a lot about what's going on up there, and what to expect. But and that's called the Wilson cloud for anyone with nuclear stuff, named after Scottish physicist.
No. Okay. You're saying Charles Wilson. He invented the cloud chamber, which is actually something. It's actually really easy to build one. It's a really cool sort of science fair project to build a cloud chamber. But what was interesting is that a cloud chamber is used to detect subatomic particles, but Wilson was not a particle physicist at all. He was a meteorologist, and he wanted to create clouds in a laboratory. And so he created this chamber where he could adjust the humidity and the pressure and everything like that. But he couldn't stop it from producing clouds. Like no matter what he tried, because for a cloud to form, you need nucleation. You need grains of dust or anything like that for the water to condense around. And no matter how much he cleaned out his chamber, clouds still formed and he didn't want them to form. And he had, he was trying to figure out what is going on here. So what he realized that it was ionizing radiation going through the chamber, ionizing the vapor and causing it to nucleate around that path. So that's what was causing the cloud. So then the cloud chamber went from a meteorological instrument to a physics one, where it allowed you to measure charged particles. And yeah, really easy to build one at home. I built one when I was in grade 8, I think. Dry ice, metal plate, upside down aquarium, and then you have felt around the top, like a strip of felt soaked in rubbing alcohol. And then the vapor goes down to the bottom of the chamber and it super cools. It goes down below its condensation point, but without actually condensing. And once the thing has reached equilibrium, you go inside and you can see little paths of particles coming from outer space, or if you put a piece of radioactive material, you can see them going through. So yeah, just really neat experiment you can do at home.
Nice. Yeah, and then speaking of you doing that like in the 8th grade, I remember there was one comment on one of our videos that you wrote, and someone was like, "Hey," he's like, "I can't believe he writes for you. I knew him back in school. He was a genius then too." Yeah. But in any event, so what would happen on the moon? And there's obviously mostly just speculation, so I'll just throw my own. So to start, no real shockwave, obviously. There's no atmosphere, so you're not going to get that cloud, and you're not going to get the shockwave effect, which is a huge part of the, the damaging area. So, what would you see? Probably just a really, really quick flash. Like, it would not last long, right? Like,
no,
because it would be just like a super fast. So just a really big flash, and then you do have the ejection particles that are, hot and stuff. But I wouldn't think you would see much in the visual spectrum after. And then you would get like the other emissions, like infrared and stuff, would heat up around anything around it, right? But other than that, like, and the particles themselves obviously shooting off, which are going to be very damaging and stuff. I mean, what would you really see? Would there even really be much of a cloud? Like, so would it stir up the moon's dust much? And if it did, it would almost be like a cone, I think.
It would be a cone. You can see that, on the footage from Apollo 15, 16, and 17, they had the lunar rover, and you can see the dust it kicks up. And this is probably one of my favorite pieces of evidence to show people who are like moon landing deniers, where I show them the rover driving around, and it's like, look at how the dust behaves. How do you fake that with 1970s visual effects technology? Yeah. Because there's no air, so it doesn't billow. There's no air turbulence for the dust to be swept around in. So it goes straight up and straight down, and it descends at 1/6 the acceleration as it would on Earth, because you're in 1/6 gravity. You look at the interaction of dust, and it behaves very oddly. So it probably would form like some sort of cone going straight out like that, and then it would settle very, very quickly because it can't billow. There's nothing to stop it from falling to the ground.
So you have that, and then you do have the electromagnetic pulse, but I would think I would conjecture that would not occur.
No, it would not actually.
In this case.
Because you need the atmosphere. So electromagnetic pulse is when you detonate a nuclear, it does occur to a certain extent on a ground burst. The British called it radio flash, and you would hear like a little ping on the radio. But to really create powerful EMP, something that can knock out an electrical grid, you need to detonate in the high atmosphere, but you still need an atmosphere there, because it's sort of like with the interaction with the aurora, where it's going to ionize a lot of the gas particles in the upper atmosphere, and then those electrons get accelerated by the Earth's magnetic field, and that creates synchrotron radiation, to give it the technical term, and that produces the electromagnetic pulse. So if you're detonating this on the surface of the moon, and you have no gas to ionize, you might get a little bit of an electromagnetic pulse, maybe from the materials in the bomb itself, but you would not get the same effect. So it wouldn't even be good for knocking out your enemy's electronics. You could maybe build an enhanced radiation weapon, that's called a neutron bomb, where there you build it with some a thin tamper. Like, you basically eliminate as many materials that would get in the way of the neutrons, so that the thing produces a huge burst of neutrons, and then you would kill every living thing within a certain radius just through neutron irradiation. There's a myth that they developed this because, you could kill everybody in a city, but the city would be intact. No, No, and a neutron bomb has the same power as a regular nuclear weapon. It would still destroy things. It was actually for tanks. So if you had the Soviets going across the Fulda Gap from into Germany, you would set off these nuclear weapons, and it would penetrate through the tanks and kill the crews inside.
Yeah. So thinking about it, I just don't think a nuclear weapon on the moon would be like the most effective weapon in the world, basically.
No, and even for the project that Carl Sagan worked on, like, can you imagine how anticlimactic that would be? Where it's like everybody's gathering and saying, "Oh, we're going to set off a nuke on the moon," and then it's just you're looking at the moon, and you see this little whoop,
yeah,
and that's it. Go America.
So you think you could see that one was probably started by someone who's like, whoa, what if we did that massive mushroom cloud on the moon like that? How cool would that be? And then, they're like, the people who actually know what they're talking about are like, no, that's not gonna happen.
Hits blunt. What if we set off a nuke on the moon?
Yeah, so basically, there's so many projects back then that you could totally see. There's just like, let's do it, but in space. It's way cooler. So moving on to more conventional guns, which would be more effective. So let's see. Oh, I did want to mention, NASA actually has had one instance of someone in a spacesuit out on a spacewalk where their suit got punctured. And it's funny because NASA knew, the ground control knew it happened, but the astronaut never actually knew it happened because his skin instantly sealed the tiny little hole. Like it just, and he ended up having like a little red mark, but he didn't think anything, of it at the time when he was, he's concentrating on his work. And they didn't tell him until afterwards because they didn't want to stress him out. So they just, nothing seemed bad to be happening. So they were just like, we'll continue with the mission.
Well, that's kind of the opposite of Joseph Kittinger, who was the one in 1959 who did the highest altitude parachute jump for Project Excelsior. He was testing out a special parachute. His glove failed on his spacesuit and his hand just swelled up and was temporarily paralyzed. This was on the way up. He could have said something at any point, but he didn't want to scrub the mission, so he didn't tell the flight surgeons anything. And he jumped with one hand, basically his entire arm completely useless, and broke the world record. It wasn't until afterwards, oh yeah, by the way, my spacesuit failed. Like, what? Why didn't you tell us? Didn't seem important at the time.
The myth from like movies, you always see, except for Guardians of the Galaxy did this one okay, except for a few little things. But most movies, the spacesuit's done and the person like implodes or explodes or whatever. But in reality, with near vacuum chambers and stuff, experiments have been done, and just on animals too, unfortunately. They did one on dogs and they expanded to like just like a big old balloon. But then if you just brought the pressure back within a certain time span, basically enough where the heart doesn't die. So, they were fine. Like they recovered fine. And in humans too, I think it was 1 to 2 minutes it's speculated that you could survive if you got back into a chamber, which is just crazy.
Yeah,
You're just gonna blow up like a balloon.
There was a spacesuit tester for NASA. They were testing the Apollo spacesuit in a vacuum chamber. He was in a hard vacuum, and a hose broke on the suit, and he was exposed to hard vacuum instantly, and he immediately passed out. And the thing he says he remembers right before he passed out was the saliva bubbling on his tongue. Boiling off because you're in a vacuum and all liquid. And actually, that's what would kill you, is the fluid in your lungs boiling off, and the alveoli, the little sacs that allow you to exchange oxygen and carbon dioxide, collapsing, and you basically get instant horrible emphysema that stops you from breathing. But yeah, he passed out immediately. There's actually footage. There's black and white footage, like CCTV footage of him just, in their suit, and then suddenly just falls over backwards like a turtle. And they repressurized the chamber. They came in, opened up his suit. They didn't even need to give him any oxygen. He just came to immediately, and he was fine. He said that about the only lasting effects was one of his ears was painful for a couple of days because of the pressure change, but that's about it. Yeah, your body is remarkably resilient. It's good at keeping the blood and everything inside of it.
Oh yeah, so I was doing a video on this like a decade ago, but they were talking about what would you want to avoid if you by some confluence of events found yourself floating in outer space. What would you want to avoid? And it was just as you said there, you don't want to try to hold your breath, because you want to just let it out. Like, do not try to restrict that passage of very rapid expansion of gases out of you, because if you do, you're just going to pop, you're going to damage your lungs.
Yeah, it's called barotrauma. They teach you that in scuba diving, actually. I've taken scuba diving training, and yeah, when you have to do an emergency ascent, like if your equipment fails and you have to swim to the surface, you blow out, like they say, hum a tune or something like that. Otherwise, your lungs are going to expand as the pressure drops, and a lot of people have died, like people trying to escape from submarines who held their breath. And it's one of the few major inaccuracies in another favorite movie, 2001: A Space Odyssey, when Dave Bowman escapes he jettisons himself from the pod to get into the airlock. Very accurate scene. You even see the moisture inside the pod condensing as he comes out. It's neat, but you can see him holding his breath before it goes out. It's like, he would have died. If he'd emptied his lungs, he probably would have been able to pull it off. But he was dead.
Yeah, well, that's what I thought. The Guardians of the Galaxy actually did this okay as well. The other thing people don't think about is you're also going to have the expansions of gases in your guts. You're just going to blow out like any matter in there. So Peter Quill is going to be very smelly after he came back in.
Well, and that's why high altitude pilots and astronauts, they give them a low residue diet. Like the classic with NASA astronauts is steak and eggs before you launch. Because they don't want them to eat things like beans and get intestinal distension and things like that, because not only is it going to be really smelly inside the spacecraft, it's going to be painful too, and you don't want to incapacitate your astronauts. But something that Guardians of the Galaxy did poorly is they show Peter Quill instantly freezing, like his face turning to ice. Well, no, because for something to freeze, the heat needs to be transferred out somewhere, and there's only 3 ways you can do that. Conduction, convection, and radiation. He's not touching anything. There's no air. So the only way you're going to lose body heat is through radiation, through infrared radiation coming off. And that takes a long time. So you would not freeze instantly. You would not just turn into an icicle. It would take quite a long time for your body to shed the heat needed for you to actually freeze solid.
Well, that's what I think a lot of people, it's like they talk about like the space is cold. In the space, I mean, you're in a near vacuum, but basically, for all intents and purposes, you're actually very insulated. Like you have trouble overheating at times.
Yeah. Well, that's the thing is like, what's the definition of cold? Like cold is the molecules in the medium surrounding you are moving slow. Hot is when they're moving fast. When there's no particles, there's no medium around you. How do you define that?
Exactly. So let's see here. This brings up this isn't on this one, but so Apollo 13, a lot of people are like, so you have the astronauts and it's cooling because their ship is designed to dissipate that heat because they don't want it to overheat. And so a lot of people, I had a question once and we did a video on it. Oh, why didn't they just put on their spacesuits to stay warm? And of course, so you have the bulky nature of things and all that, but I just thought it was interesting. It gets down to that, that one also kind of reinforces they're going to freeze because they don't have heaters. It's really just because they would have overheated if the ship wasn't designed to dissipate that heat very rapidly and everything.
And that's the thing with the spacesuits. That was always a huge problem with spacesuits, is how do you get rid of the astronaut's body heat? And that caused a lot of problems. There was one of the Gemini missions. I think it was Gene Cernan. We were supposed to go to the back of the Gemini and pick up this jetpack. Basically, it was designed for the Manned Orbiting Laboratory, which was the Air Force's space station project. So he was supposed to go to the back of the capsule, put on this thing, and fly around with it. But since they didn't put any handholds or anything that he could use to pull himself to the back of the capsule, which was a huge oversight. I never understood why they didn't think of that. They gave him nothing to hold on to. He was exerting himself so much, and his spacesuit was air-cooled. It was just cooled by the oxygen flowing into it, and that overloaded it immediately, and his whole visor fogged over. He couldn't see a thing. And it was only, if I remember correctly, he had to lean forward and push his nose against it to open this tiny little window, just so, those of us here who live in the frozen north, it's like, oh, I'm late for work. I'm going to scrape a little tiny little window in the frost on my windscreen and and drive to work that way. And then, barely made it back into the capsule. In fact, his suit had ballooned. This happened to Alexei Leonov, the first person to do an EVA. as well. His suit ballooned so that when he finally got back into the capsule, sat down into his seat, and they started closing the door, it wouldn't close. And so his crewmate had to basically squish him down, and like almost broke his back doing this. Squish him down so that the door could finally close, and then they could repressurize the interior, and then finally he was fine. But so later they came up with a liquid cooling garment where you have basically long johns covered in little plastic tubes that you pass cold water through, and that was the effective way that they found. They still use it to this day. So when in Gravity, when Sandra Bullock comes out of her spacesuit and she's just wearing a tank top and undies, no, you'd be wearing a far less sexy liquid cooling garment. You'd look like you're wearing a really geeky union suit.
Yeah. Oh, and I wanted to say, speaking of, you said like he uses his nose to like, clear out a little space. They also used to do a little alternate. I mean, Velcro became very popular because of like that. You could stick things to it and it doesn't float away. But they also would, or at least NASA did, I don't know what the Soviets did, but they put a little piece of Velcro on the thing so they could itch their face and their nose and stuff. If kids obviously no way to do it.
Absolutely.
And so that was kind of a funny little thing.
Yeah.
But
although they ended up being too obsessive with Velcro, this is one of the things that led to the Apollo 1 fire, the disaster, was they basically coated the entire interior of the capsule with Velcro. They had Velcro everywhere, and everything was made out of nylon. And yeah, nylon's great. Nylon doesn't burn all that easily in ordinary air, but in 100% oxygen, it's basically explosive. And that's what fueled most of the fire, was that they just jam-packed this thing with Velcro.
Yeah, it's amazing how much that they thought of, and then like, some of these little oversights of just, So going back to where were we? We were talking about conventional guns and their more rapid fire nature, which is going to be way more effective than nukes, especially when the things aren't really possessing much in the way of armor. Although again, they were thinking more of the Iron Man suit. But there have been guns as part of the Soviets particularly had it as part of their thing. So we have the TP-82 Cosmonaut Survival Pistol, designed in 1981 by Igor Alexandrovich Skrylev. What do you think?
Close enough.
Yeah, okay, cool.
I've Russian friends who'd probably be like, what? No.
There's in videos, I'm famously bad at French and German or worse, but
Russian is a whole other kettle of fish.
Yeah, people often think it's like not preparation. No, it's just that I'm really bad at it. Like I have the thing. Sometimes I'll even like pause and I'm sitting here listening to someone say it correctly, and then I put the thing down and I read it, and it's just still butcher it completely.
And that's the thing, is like I don't really fault people all that much, because if you didn't grow up with it, like there's certain sounds that are really hard for a non-native speaker to make. Like I'm fluent in French, but if I get somebody to say like the word for frog and the word for deer are grenouille and chevreuil, those last vowel sounds, I challenge any Anglophone to try them on the first go. I do not blame you if you can't pronounce those. They're very particular to French.
Well, and your name itself has, I feel like, some of that, because if you watch your videos, you have a video where you actually say your name very distinctly and stuff, but when you normally do it, to my ears, because I'm no French experience, it sounds like you're saying something completely different when you say it together versus when you on your video where you say it very distinctly. And it's fascinating because I know you're saying the same thing. I mean, it's your name, you're obviously, but it sounds so different to my ears, even though, it's the exact same. It's fascinating to me. Where were we? Oh, yeah. So he developed it at the Tula Arms plant. It's a 36 centimeter long and weighing over only 2.4 kilograms. Two smoothbore shotgun barrels chambered in the proprietary 12.5 by 70 millimeter shell, roughly equivalent to a 40 gauge. And then it had another rifled barrel chamber, which 5.45 by 39 millimeter cartridge, same as the AK-74. But this was not, even though it was part of the astronauts thing, it was not meant really for space. It was really for survival afterwards because of some incidents they had where they're landing off in the wilderness. Yeah,
especially Vokshod 2, which was when Alexei Leonov did his spacewalk. They came down in the middle of the Ural Mountains, and there were wolves stalking around their campsite, and I think they gave them a Makarov pistol. They're like, well, that's not going to be good against a wolf or a bear.
Well, and on that one too, when they landed, they also had, because of the reentry, they had like just sweat pooling by their feet, but it was like freezing outside. And yeah, on that note, they did have. Was it this one? I think they had the detachable shoulder stock that worked as a machete for chopping firewood.
Yeah, that's on the TPM. Yeah.
So yeah, and let's see, it uses expanded soft point bullets, which are those are illegal, in warfare
for use against humans, yes. But this is actually very common. I just recently did a video on my own channel on survival rifles, and it was very common to give aircrew rifles, usually chambered in very small calibers like 22 rimfire, 22 Hornet, for hunting small game, and those were allowed to have soft points, but the box for the ammunition came with a giant warning on it that said, "Do not use against people." If you use soft points or any sort of expanding ammunition, it's in contravention of the 1899 Hague Convention.
Oh, nice. And then they had another one, would you say TOZ 81, or is it like TOZ 81?
You would say TOZ. Well, TOZ is the abbreviation for the Tula Arsenal. They make a whole bunch of different firearms.
Okay. Yeah, so it was just a double action revolver with a 5-shot cylinder, but this one was cool because it had a radio transmitter built into the stock, detachable, and then it also had a flip out survival knife, it's kind of like a Swiss Army knife gun, like do lots of things. There's also that one. What was the one that's the knife gun? Have you seen that one?
Oh yeah,
where it has like one shot.
It's a ballistic knife. That was a Spetsnaz thing. Yeah. There were two different. One of them had I believe a 22 caliber like single shot gun in it, and the other one, the ballistic knife, had a very powerful spring, and it would shoot the blade out. And, and it's funny. There are a lot of places, weirdly enough, that the ballistic knife is illegal, but you can carry a regular handgun. It's one of those weird things where I think bureaucrats looked at it and said, "Oh God, that's insane. We must ban that," not realizing that it's much less convenient and useful than an actual firearm.
So these guns obviously were not really meant for use in space, but there was one gun, an actual spacecraft, equipped with one, in response to the manned orbiting laboratory that the U.S. did in the 1960s, with surveillance cameras and everything. The Soviets wanted to do their own thing, so they did the Salyut space.
Salyut.
Is that how you pronounce it?
Salyut.
Salyut. Okay. They did that project, but also called Almaz. And their third one on that was launched on June 25th, 1974. And it had the
Nudelman Richter
cannon, which they actually supposedly did fire once.
But it was fixed to the bottom of the whole space station. And it was unmanned at the time, I believe, but they had to maneuver the entire thing to actually aim and shoot it. Talking about Salyut and Almaz, they were basically the same thing. Salyut was the civilian space station, and then whenever they wanted to launch an Almaz military station, they gave it the cover of making it Salyut. So I believe it was Almaz 2 was actually Salyut 3.
Okay.
So it was a military station, but with a civilian cover name. And the Americans did this too, like the Corona satellites, which were their spy satellites. They were called Discoverer as their civilian designation, so that people wouldn't know that they were spy satellites, even though the Soviets were perfectly aware that they were spy satellites. But those were cool because of how they actually recovered the photographs, because they didn't have the technology to transmit images in high enough resolution remotely. So all the film, it was actual film, would be rolled up into a little capsule that would then detach, re-enter the atmosphere, and then they had, typically it was a C-130 Hercules, flying above the recovery zone, and the thing would come down on a parachute. In midair, they would snatch it with a hook out of midair and pull it into the aircraft, and then so that was how they recovered those, and it was very effective. I don't think they lost very many of those capsules. They recovered quite a lot of the photography from those.
This gun in particular could apparently, I don't know if in space, like I don't know if we know that, but the actual version on Earth could do upwards of 5,000 rounds per minute, which is insane. But they apparently, here 20 rounds successfully, and they supposedly destroyed a target satellite with it.
And contributed to Kessler syndrome. Thank you, Russia.
Yeah, but then they abandoned that later on, which it's just funny, like having these satellites with like a big old, really effective machine gun, basically just, equipped just because.
it doesn't take much to damage a spacecraft. Like I remember on one of the space shuttles, they came back and they found this giant divot. Well, it was about that big in the window, one of the windows on the space shuttle, and they found that it was a fleck of paint traveling at orbital velocity that had gouged this big crater in the window. So when things are going that fast, it doesn't take a very massive piece of space junk to do a lot of damage. But interestingly, the Russians did try to develop a handheld space gun. It was actually a laser gun, weirdly enough. Yes, so it wasn't powerful enough to actually burn holes in things, but it was meant to blind the sensors on enemy spacecraft or even blind a person. And it was basically the best way I could describe it is like in the early Iron Man films, where he's got like those single shot lasers where he like fires one powerful laser beam and then the thing ejects. So it was a flash bulb fueled by zirconium in oxygen. And then there was a piece of ruby, like synthetic ruby. And the idea is that you would fire it and it would make this big flash, and then the ruby would convert it into a laser beam. And they had a single shot version and a revolver version where you could fire these little bursts of laser light to take out sensors or blind astronauts that were coming towards you to take over your spacecraft. Yet the Soviets were very paranoid that the Americans were developing spacecraft to go and steal their satellites or go spying. It's one of the reasons they developed their own space shuttle, which was Buran, because they thought that the American space shuttle was going to go and steal their spy satellites, which it couldn't. They were too high altitude for it to go up there. But then they ended up building a better space shuttle, actually. Buran was superior in many different ways because they didn't go for solid rocket boosters, which were the big dangerous things on the space shuttle. And they didn't go for the big external fuel tank. In fact, they didn't have engines on the orbiter itself. They had jet engines, actually, so you could actually, if you missed the runway, you could do a go-around.
Really?
Yeah. The Americans wanted to do this as well. The early plans for the space shuttle called for it to have jet engines so that you could actually land wherever you wanted to and do a go-around, and you weren't basically flying a brick falling through the air. Mm-hmm. But due to cost savings and weight savings, they eventually deleted that and turned it into a glider. And what's really funny is, you know how they trained American astronauts to land the space shuttle was with a Learjet with its fly-by-wire system modified so that it flew like a brick and with the thrust reversers on. So the thing would basically just fall out of the sky and they had to land it.
Yeah. I've always found that fascinating because you think about like I know they do all the calculations and everything, but it's still to hit that target. And there's ways, you can do little S's and things like that.
Yeah.
Hit a tiny little runway, relatively speaking, with this thing that is falling at such a high rate. And without you do simulation practice and stuff like that, but it's still like you get one shot at this. If anything's wrong,
but hey,
it's not going to work out.
But regular glider pilots do it all the time. Of course, you've got a much lower sink rate. You can float, you could go into ground effect or what have you. Your impact is not as severe as, with the space shuttle, which is basically like throwing a Buick from outer space and trying to land it.
Yeah.
But glider pilots do it all the time. You have one shot to land, and that's it. So,
and I guess it is in my old plane was a Piper Arrow, and it fly. Not like a space shuttle brick, but relative to other little planes, it will go. You do full flaps, and that thing will fall at such a rate that you don't typically want full flaps and no power because you're just going to you got to time that flare perfectly. But then that's why I was thinking with like the space shuttle, just the speed it's dropping and the flare that they have to do, like that's some good training there, and don't mess it up.
It's funny, here we have a museum where we have sort of like a science gallery in the basement. It's like one of those interactive museums for kids, but they have one exhibit there some friends of mine from the local university built, which is a simulator for the lunar module, the Apollo lunar module, where you have screens and two joysticks, and one person controls, I think, the engine, like the one person controls the engine thrust and like pitch yaw, and the other person controls other range of motion. And you have to try and land this thing on the lunar surface. It's freaking impossible. And but it makes sense because you have no atmosphere to stabilize you. You're riding on the thrust from your descent engine, and you're controlling yourself with these little gas thrusters. There is nothing to damp you out. You have zero margin for error. And trying this thing out really gives you a lot of respect for the astronauts, especially like, say, Neil Armstrong, where he had to improvise. He had to break from his normal landing routine and hop over a boulder field. Otherwise, he would have come down right in the middle of it. And just incredible. And you can see that they trained for this mission using, they called it the flying bedstead, which was basically a jet engine with legs that would fly around, and it would give you the feel of flying the lunar module. And the thing was horrifically dangerous, and Neil Armstrong almost died. He had to eject from it because the thing just went out of control. And there's actually footage of this where he's flying along, and then the thing just tips forward and starts to fall, and then out he goes.
Going back to your laser idea, so going on the moon, like they thought of some better weapons than the conventional, like the nuke. Not going to be nearly as effective on the moon as Earth, and guns are better, but still there's better option there. And they, of course, being a space station, it should have a death ray. And they had this idea of just focusing the sun's rays and ionizing radiation and stuff onto a point somewhere, and that's going to be a really simple weapon that's going to be really effective with all the solar radiation and stuff. Well, at least as long as the sun's out, I suppose. Maybe
they've done, like, there was the famous myth of Archimedes building a solar death ray. And I think Mythbusters tried it. They're like, it's really, really hard to gather that much sunlight and focus it onto a small enough point, even to light a wooden ship on fire. Optics is difficult.
But I would think on the moon, because it's so much more intense without the atmosphere, and you could do a really lightweight reflective dish. It's huge.
But again, I don't know. But when you think about it, also the atmosphere is going to dissipate it, and it's going to absorb a lot of it. And are you really going to get, once it gets to the ground, are you really going to have anything more intense or anything significantly more intense than just the sun? Because you're gathering a very small amount of sunlight, and yes, you're concentrating into a small area, but that area is being bombarded by the sun anyways. Like, it would be interesting to do the math and see, like, how much more concentration, like how much more energy you could get into a certain point having to go through the atmosphere, and given the limitations on how big the moon is. Or somebody did a simulation of, if you turn the moon into a giant lens, if you made it out of glass, and it wouldn't actually do anything. It would just cast like it wouldn't do anything. Like, I think it's on Corridor Digital. They do visual effects stuff. They did a simulation where they made the moon out of glass, and it did nothing. It just cast the same shadow. Just because of the way that the light passes through it and is dissipated, it doesn't actually concentrate the light all that much.
Then they also, let's see here. As mentioned, they wanted to do Iron Man-like suits, and we have a report, to quote the report on it, they chose that over fabric because they stated, for sustained operation on the lunar surface, a body conformation suit having a substantial outer metal surface is considered a necessity for several reasons. Number one, uncertainty that fabrics and elastomers can sustain sufficient pressure differentials without unacceptable leakage. Number two, meteoroid protection, which I would think it would not be very effective against that unless it's like crazy thick. Number three, provides a highly reflective surface. Number four, durability against abrasive lunar surface. Number five, cleansing and sterilization. It should be borne in mind that while movement and dexterity are severe problems in a suit design like this, the earth weight of the suit can be allowed to be relatively substantial. For example, if a man and his lunar suit weigh 300 pounds on Earth, they will only weigh 50 pounds on the moon. But of course, that provides issues with their movement and stuff. The fabric ones do to an extent too, because of the swelling, like you said. But
but not really. Like NASA Ames Research Center is developing a suit like that, and they find that it has 95% of the mobility of a person without the suit. Although, there you get, again, with the regolith, the lunar dust, then you get a problem because, you have to have very tight tolerances for these parts of the suit to slide over one another without leaking. If regolith gets in there, it can tear those to shreds. And it's a similar challenge to, I wrote a video recently about atmospheric diving suits, where it's the same thing, but in reverse, where, you build basically a suit of armor to dive underwater. And the big problem there is creating joints that can move freely while still resisting the pressure. And one of the big advantages of a rigid spacesuit like that is you reduce the risk of decompression sickness, same as with a diving suit, because if you have too much of a pressure differential between the inside and the outside of the suit, it's not going to be very flexible. You're going to be basically the Michelin Man floating around in space. So they run them at a lower pressure than the spacecraft, because the spacecraft has rigid walls, and so you can run it at a little bit of a higher atmospheric pressure. So astronauts need to pre-breathe oxygen before they get in the spacesuit, because otherwise they could suffer from the bends, because they're going from a higher pressure environment into a lower pressure environment, and nitrogen would bubble out of their blood. So with a rigid spacesuit, you would be able to run at the exact same pressure as in your spacecraft or your lunar base or wherever you are. So that's one of the advantages there. But yeah, it's difficult to maintain the seal on that and still allow it to be flexible, and especially with regolith tearing it apart, you'd have to replace the seals on those suits pretty regularly. And when they're talking about meteorite protection, they're not talking about like, something that big or, the size of your fist or something. They're talking about micrometeorites, like things the size of a grain of sand. And the Apollo spacesuits and even the suits today, they do provide a certain amount of protection because they're covered in what's known as beta cloth, which is basically fiberglass coated in Teflon. So it's like having a bunch of fiberglass insulation, and it can actually trap those little tiny micrometeorites where they're not that dangerous, but they can still puncture your suit, but it's very easy to protect against them.
And don't they, I could be wrong on this, but I vaguely remember quite some time, don't they also design it with the layers such that it will try to vaporize the thing hitting it? I think you're
talking about a Whipple shield. So this is used on certain spacecraft parts. But yeah, Whipple shield is multiple thin layers of like aluminum or something like that, where when it goes through one layer, it disintegrates, and then it has less energy, and so it has less energy to penetrate the following layers. And so it allows you to make a fairly lightweight shield that can still block high velocity objects. But, that's kind of a little bit, take that to the next extreme. For tanks on Earth, they have something called reactive armor, where it's basically like a sheet of explosives on the outside of the tank. And so when a penetrating round or a heat round, a high explosive anti-tank, shape charge hits it, the armor actually explodes and basically negates whatever momentum, destroys that penetrator. So you sacrifice that block of armor, but it doesn't allow the penetrator or the jet of molten metal from the shape charge to actually reach the hull of the tank.
So going on this, another thing Project Horizon, the report also did, I just like this part, they suggested creating, I just like the name, a unified space command, which would be in charge of further exploration of space, a fleet of spaceships, potentially, like getting that built and whatnot, and any objectives that deemed, deep space missions, whatever. The unified space command would be in charge, of course, instead of NASA. But it's kind of a fun name.
Yeah. Again, you can see the armed forces trying to claw their way back into space.
Well, and it's so much of the stuff they keep trying to tack on, like the militarization of it, when it's just like, is that really a good use of money? Like, as far as the like, what do we need that gun on there? No, like let's just make it without the gun. It'd be a lot cheaper. And again, they finally realize a lot of this stuff is much easier to do unmanned. Like both the US and the USSR tried to build these manned space stations for Earth observation. They both realized satellites can do it a lot more easily, as they both just switched to satellites. So, and then as speaking of all that, with the cost of the project, the report states, the total cost of the 8.5-year program presented in this study is estimated to be $6 billion, which is about $60 billion today. Yeah. This is an average of approximately $700 million per year. These figures are a valid appraisal, and while preliminary, they represent the best estimate of experienced non-commercial agencies of the government. Substantial funding is undeniably required for the establishment of the U.S. lunar outpost. However, the implications of the future importance of such an operation should be compared to the fact that the average annual funding required for Project Horizon would be less than 2% of the current annual defense budget. And going on that, so the reality, of course, is the Apollo thing cost $25 billion for the whole project. So this $6 billion estimate is probably a bit light, but it's still even Apollo was really a small portion of the U.S.'s defense budget at the time, so which was at about $50 billion per year. And so we're talking $25 billion over the entire span of the Apollo program. And so that $50 billion at the time was about 9% of the GDP, which is a lot compared today. It's more like 3.5%, but the U.S. now spends just shy. It's $900 billion per year. So that's a lot. And just to put that in perspective, so if you want to break it down like if every citizen was taxed equally, which obviously is not a thing, but it's about $2,700 per year per person. If you compare that to the number 2 in the world in military spending, which is China, they do it at only 210 equivalent US dollars per citizen. But I mean, granted, they have 1.4 billion people compared to 335 million. But the next up in the UK, the highest in the UK the highest in Europe is the UK at $109 per citizen. But to really just like put into perspective how much the US currently spends on, and it's gone up a lot in the last couple decades, but 37% of all military spending in the world every year is done by the US, over 1/3. And next up is China at 12%, and then Russia is third currently at 4.5%. And then surprisingly, this one surprised me, India is number 4 at 3.4%. That's a fascinating one.
Well, and then it doesn't surprise me at all. I mean, you look at
Really?
India's been fighting Pakistan over the Kashmir for ages. They have there's basically been a Cold War there for ever since Pakistan was formed.
That's true. Yeah, you just don't think of India as being like a major spender in military, but I guess that makes sense. Then number 5 is kind of tied for Saudi Arabia and the UK at 3.1% of their GDP. But I do want to do sometime, because the U.S. military is sort of like has this policy since the Cold War, basically. We're just going to go so overboard in spending and military equipment and all the technology that no one or even a group of nations would ever dream of attacking. But then you think about like the change now, if it still makes sense in the modern world as sort of efficiency of helping your citizens, as far as like what could you use some of that money for otherwise? Because you can always do that like 20% of the effort to 80% of the results, which is the US does like 100% effort, 100% results type of thing. And you could save a boatload, and then where could you put it elsewhere? And if it makes sense given the geography of the Americas and the interconnectedness of businesses. And I don't know, it's such a nuanced topic. It would be such a big one because I don't really know. Does it make sense when you do that? When you consider all the nuance and all the ramifications of if the U.S. suddenly was like, we're going to only spend 20% of what we currently do, probably be just as safe, like as far as actual safety. But what would be the widespread ramifications of like, the U.S. patrols the shipping lanes and like these sorts of things, all these sort of things that might, and sort of like, what would be the ramifications that you wouldn't think about? But it's a lot of money. Like when you really step back, and then you think of projects like the F-35 or something like that. And you think, is it necessary? You look at some of the stuff with like Russia and the Ukraine, where it's like, we have like these cool technologies, but you have these $100 drones that are super effective at countering. And where I sort of just the modern technology, modern warfare, and also like cyber attacks and things like that, which are, cheap relatively and stuff like that. I just think it'd be a fascinating and super long think piece to just see all the widespread ramifications of everything and whether the policy still makes sense. But I don't know. Thoughts on that from the Canadian perspective?
I don't know. It's because it is difficult. Like you're talking about spending on the F-35. Like there's been a lot of misinformation, a lot of misunderstanding about that. Like you look at, I think the war in Ukraine, yes, you're talking about drones, but if you look at Russian equipment, we've always been praising it for being, sturdy and hardy and simple. And no, they're failing because, the guy has to bring a Garmin GPS in his cockpit, whereas the F-35 actually has proper targeting sensors and it can actually do things. And yes, it's an expensive aircraft, but military procurement is always very expensive and you need that capability on the modern battlefield. So there's I think there's a lot more subtlety to it, and that would make for a very interesting discussion, because like a lot of the things that we take for granted, like again, that the Ukraine war exploded a lot of the myths that have been circling around about what makes effective military hardware. It turns out the West was doing it right. Like as expensive and as wasteful as we think that military spending was, like no, that technology actually works. It actually makes a difference.
Well, and you also talk about the other thing to consider is the U.S., the Department of Defense employs in the U.S., like, I don't remember the percentage now, but it's a lot of people. And so that tax money is not just going for nothing. It's also employing a lot of people. And where would that shift if you suddenly cut this? But I think it would be a really good think piece, and it would be really long. And I don't think there would be any conclusive answer, but it would be kind of interesting to work through it all. So let's get back on top here. Going back to the moon base, we have, while the military, of course, was trying to militarize a lot of the stuff, They actually didn't really think of it as that's going to be the purpose. They were well aware of a lot of that. I think like you talk about, they're just trying to like insert the military aspect of it, but it was actually really meant for scientific discovery. Like that was kind of the realistic that it would actually be used for. And so it's very unfortunate that it never came to be because of some of the implications and some of the cool things that could have just been happening. And but at the time, contrary to popular belief, the greatest generation was not enthusiastic about the whole space race. There was a Gallup poll that showed 2/3 of Americans were against the moon landing at all, let alone like a project like this. They just thought it was a waste of taxpayer money. That was the prevailing thing. But it was really, like Kennedy was having none of it. And yeah, so he kind of pushed it regardless. And then people, everybody loved it. Like it's inspiring worldwide. Like this is something cool thing we did. But then directly after, everyone was just like, all right, we did that. Let's do something else, which is where the space station would have been way cooler because there would have been so much more follow up. It's not just like, let's send, we have this base there. Let's do something cool with it.
Yeah. There's that line in Apollo 13 where it's like, oh, you guys they say that you make the moon landing look as exciting as a trip to Pittsburgh. Like, yeah, like after Apollo 11, people really stopped caring.
And that's where they need it because you're sending people and they're doing experiments and stuff like that, but it's just not like, I don't know, it's not like inspiring, as you say. And something like a space station or a moon base, I think would have been just cooler, and especially with more people. And I don't know, they and also NASA could have used like some really good storytellers to like craft it a little bit like a reality TV now, where it's just like it's really kind of like crafted around something. They could have done something
Big Brother
like that to make
on
it a
the
little
moon.
more inspiring. Yeah, exactly. We'll put these astronauts in one little space together. Let's see what happens.
Although I don't know if it would have had that much staying power, because you've got astronauts, they've been on the ISS. Like the ISS has been continuously occupied since 2000, I think. And yeah, occasionally you'll have somebody like Chris Hadfield who will stoke interest, but how much do people think on a regular basis about what's going on aboard the ISS, unless something like the Boeing spacecraft that's stuck there.
Yeah, that's where they have a bit of a PR problem, because they had these interesting stories with the Apollo missions and things like that, but they would like suppress the most interesting parts. Like there's the funny stuff that would happen, or a lot of the astronauts very non-professional talking and speeches. They would almost suppress that from the news and make them these like mythical figures of like, and they're dehumanizing them in some respects. They're like unrelatable, whereas if they would have, I think, like put these more stories of like the things, people would have been way more fascinated with it.
Those guys were hilarious. You read the transcripts. Like one of my favorites where they knew about this the censorship and what could or could not be broadcast. There was I think this was during one of the Mercury flights. This was, Wally Schirra. I believe it was Wally Schirra. I might be incorrect. Where there was a joke that the astronauts had, which was the Turtle Club. So the idea is you say, hey, are you a turtle? And you say, the response is, you bet your sweet ass I am. If you fail to say it, you owe everybody a round of drinks. So while Wally Schirra is orbiting, one of the capsule communicators, of course, is a fellow astronaut. I think it was Gordor Cooper. I can't remember who it was, but he said, "Hey, Wally, are you a turtle?" And he knows that he can't say, "You bet your sweet ass I am" on an open line. So he switches. There's an onboard tape recorder that he can record his response into. So in the NASA transcript, it just says "response recorded." You just put it in a tape recorder.
There's so many little things like that. There's the funny one where they had some poop floating around, and then it was just like, who did it? And they're all like trying to decide, and they're joking around. And that stuff, like that they should be like making that front page. Just, it gives the human element. It's why like Apollo 13 had so much human element in it inherently, and everybody's captivated by it. And you see that in so many like history books. It's something that they take the human element, they make these figures really mythical, and it's just like you cannot relate to them at all. And so people are bored by it. But when you actually deep dive into like their journals and these things, they're really fascinating, and they're every bit as good as like any Hollywood movie. And that's the Hollywood movies take that out and tell that side of the story. And if they would just do that, like if NASA would have that like as a priority of like, we're going to start doing this and we'll give like, these are human beings and this side of it, people would just get super fascinated. And I feel like it would help a lot.
Oh yeah, but sometimes you have the opposite problem. Like I remember not liking the movie First Man with Ryan Gosling, because The thing with Neil Armstrong is he didn't have a huge personality like a lot of the rest of the astronauts. Like Buzz Aldrin has a lot more personality. That's why he's still, he's still beloved to this day. But Neil Armstrong really didn't have anything going on. Like, he was very professional. He was very soft-spoken. I wouldn't say he was boring, but compared to all the other personalities, like especially like Pete Conrad and Alan Bean and all of those other guys who were, massive pranksters, he wasn't. He was just a very competent pilot, very smart guy. And so the movie tries to go to the lengths to give him like a very tragic backstory and what have you. And it's just like, well, no, that's not what he was. It's very difficult to make a Neil Armstrong movie because there's really nothing you can grab onto, because he was just a very, friendly, competent, very intelligent, and rather quiet guy. And it's kind of hard to build something around that.
Well, and that's exactly like but yeah, that's exactly, your point is exactly right. But they would try to build around that.
Yeah.
Like that was what they were like, he's the ideal, he's what we want, and we'll make everyone else seem like that. But it's like, yeah, that's not interesting to people. People are just gonna be like, oh, well, it's boring. Like you're boring.
And they were doing that all the way back in Mercury, where they were really pushing John Glenn because he was like the all-American guy, and the guys around him, like Gordo Cooper, was a huge personality. They really did him well in The Right Stuff. Dennis Quaid, and Alan Shepard, total horn dog. I think you had a video on him before. It was like Don Draper in a spacesuit. These were huge personalities, but no, they wanted the clean cut guy. They even forced Cooper to get back with his wife who'd left him, because they all had to be like upstanding family men. He had to go back and he had to tell his wife, hey, look, I'm not going to get into space unless we get back together. Can you please pretend for the cameras?
Yeah. And that's where I feel like they could have used like some really good storytellers to be like, all right, we're gonna do some narrative for you. We're gonna take these personalities, we're gonna show them to be. Now, granted, in the 1950s, 1960s, people might not have reacted as well, especially to government spending on taxpayer. And people today would have that argument, but I would also argue that they should, do it anyway, because if people. Yes, you would have these people complaining, but at the same time, you'd have a lot more people engaged in like loading up the news and wanting to read about these interesting stories and these interesting people doing these cool things in space.
And it doesn't take much. I mean, it didn't cost anything more for Chris Hadfield to do all of the outreach that he did when he was on board the ISS. He just made a bunch of videos and played the guitar, and people ate that up.
Exactly. It's the same with when we cover stories of anything history-wise. It's kind of like some work I'm doing for Quincy. I'm writing a book right now, and it's the same thing. It's like when you read a lot of these stories from like a history book, it's really boring. But if you really dive into it, like John Adams and John Quincy Adams and these characters, like they were fascinating and they were really interesting people, and they have so much of their journals and stuff have survived. So many of their letters, their personal letters, have survived because they were very obsessive about documenting everything and being brutally honest. Even because like there's one quote where John Adams is telling John Quincy is like, you have to write honestly for posterity, because also it's for yourself to reevaluate yourself in your journal, to be like, and so if you're lying to yourself in your journal because you're thinking, oh, somebody's gonna read this later, well, you're just lying to yourself and you're not going to perfect yourself. And this was a big thing. So it's very honest, and it makes for really fascinating stories. That's partially why I wanted to write the book. It's just really interesting.
Yeah, and there's a huge survivorship bias thing, which is that a lot of what survives about people from the past is sort of official records and them putting their best face forward. And we tend to forget that people in the past were people, that as human beings, we have not changed all that much. Like you read the filthy graffiti on the sides of Roman roads, where they're just full of like yo mama jokes. And it's like, yeah, we haven't changed. People are people.
Yeah, it's exactly that. And like Napoleon is another good one, because Napoleon, you think of this like legendary general, and he made a lot of mistakes, but like it's this mythical figure. But when you read his letters, which are quite a few, surviving between his ex-wife, because he had to leave her because she couldn't couldn't get pregnant basically, and he wanted an heir. But you read his very personal, and it so humanizes him so quickly, because he's venting to her constantly, just like she's a little bit of his support, because they stayed really close after their divorce, and he's constantly just like worrying about this, am I doing the right thing here, like all his like. And he's just venting completely to her. And they're in these letters, and it's like, oh, he's just a guy. Like, he's just a guy, and he's in a, the heavy as the crown, type thing, where he's just worried about everything. And it makes him a lot more interesting, and more stuff like that just makes the stories covered more interesting. It's just like, oh, wait, that's just a real person. Like, trying to react to the crazy situations.
Yeah, there's a funny one that's it's been floating around, which is a journal entry by Charles Darwin, where he writes like, "I am very poorly today and hate myself and everyone," and it's just like, we've all been there. It's okay.
Yeah, no, exactly. And that makes people relate to the person, and then that makes them want to read the story or learn about this bit of history. And if you do it accurately from there, you can have, and it's like so many historians will take the characters out of the events and they'll just talk about the events. And it's like, that's not, I mean, it can be a little interesting, but like, that's not going to have mass appeal. Put the characters back in and tell them accurately and as they were, and then it becomes something people, I mean, Hollywood does this all the time with movies. You know, they take liberties, of course, on certain things, but for the, you can even sometimes do it very accurately and a lot of people still want to watch. It just, yeah. But anyways, going back to how about, so that's, yeah, that project got canceled, obviously. And then the Soviets also, the funds from that went to Space Shuttle and everything like that instead after the Apollo, and the Soviets also abandoned. But it's interesting, even when you're talking about the cost of all this, you look at the entire cost of like the entire cost of the Apollo program. The Vietnam War was 7 times that costly. And it's like, that's a very less inspiring way to fight communism. And also, you know, sending 2.7 million of basically, you know, the taxpayers' children and taxpayers themselves off to war. Maybe not as cool. The space one's a little more inspiring. But how about now some space moon bonus facts? So what are we going to start with here? We'll start with Neil Armstrong. Every time we do this quote, someone will argue one way or the other, whichever way we do it. So we say that's one small step for a man, one giant leap for mankind. Or sometimes we'll say it one small step for man, one giant leap for mankind. And either way, people say it's wrong because when you actually listen, it sounds like he said it the wrong way.
Yeah, I've heard that correct me if I'm wrong, I think he's claimed that he said it as a man, but it just gets garbled. Yeah, they've gone over the recording over and over again. And if he said it wrong, well, who cares? Like, to be able to say anything articulate in that moment when you are the first human being to set foot on another world, you cut the guy some slack.
Yeah, and that's what he has a quote. I didn't write it down here, unfortunately, but for the most part, he argued that he said it the right way because that's what he intended to say.
Yes.
But after there was someone did like an audio analysis, and it just kind of seemed like he probably just flubbed it, and that he kind of was like, he looked at that and he was like, yeah, I might have. Obviously, he doesn't remember. His kind of mind was on other things at the time. Yeah. But he's like, I might have, but I would hope history would say like, all right, that's a human being stepping foot on the moon. I'm, you know, my mind is, it's hard to remember to say the right thing. But you guys know what I was trying to say either way.
And then, and you have Pete Conrad on Apollo 12, who didn't even, you know, try to be profound, and because he was a short guy, he jumps off of the ladder onto lunar surface and says, "Wee, that might have been a small one for Neil, but that was a long one for me."
That's great. And see, that should be pushed more. That's funny.
Yeah.
But yeah, also speaking of things, Armstrong being slightly boring is after his momentous first thing, he continued the second thing said on the moon, which lacks the oomph factor. He just said, so he starts, and the surface is fine and powdery. And then he goes on, I can pick it up loosely with my toe. It does adhere in fine layers like powdered charcoal to the sole and sides of my boots. I only go in a small fraction of an inch, maybe 1/8 of an inch, but I can see the footprints of my boots and the treads and the fine sandy particles. It's like, that's nothing. Yeah, it's slightly less inspiring.
Well, he's going straight into, I think the first EVA was like 40 minutes. Like they're one and only, so it's like they've got to get to work. They've got a ton of stuff to do.
Yeah, he's like, I've said my inspiring thing. Now let's get to work on
down
the
to science. Yeah.
So speaking of that, what did they do afterwards besides like setting up little things? A lot of people don't know that they hopped around like kangaroos because one of the first things they had to figure out was what's the best way to walk, you know, on the moon. And they thought it would be to hop like a kangaroo, which is just, you can see video footage of this if you Google of them hopping. And they thought, but in the end, they decided after experimenting a lot of different ways, they decided that little lope that you see them do which is another thing that would have been hard to fake.
Oh, I'm trying to remember which mission it was. I think it was Apollo 16, where there's footage of them sort of loping around, and he's singing, "I was walking on the moon one day in the very, very month of December," and then he's like, "No, May."
Oh, and then they also experimented with seeing how high they could jump, which was apparently close to which one? Armstrong. He could go about 6 feet, which would be a little weird because you just your brain normally thinks if I'm going to be 6 feet up and coming down, that must have been a little weird for the brain to be like, this isn't going to hurt. Like we're just going to come down.
Well,
gently.
on Apollo 16, they did the Lunar Olympics. They started the Lunar Olympics on Apollo 14, where they took there's a pole from a solar wind collector and threw it like a javelin, and then of course Alan Shepard hit the golf ball, and then on Apollo 16 they did a couple more events, and John Young tried to do the long jump, and that almost ended in disaster because he found that as soon as he was in the air, the PLIS backpack, like the life support backpack, made him fall, like made him twist backwards and fall on his back. And it's like, I could have ripped out my oxygen hoses. I could have just killed myself right there. So it's like, yeah, we're not doing that again.
Yeah. The first person, speaking of that, it was the fourth person to set foot on the moon. Alan Bean was the first known to fall on the moon.
Oh, another fun little fact. So with the Soviets, the spacesuit they came up with for walking on the moon, I think it's called the Crockett, actually had a hula hoop built onto it so that you could roll over, so that you wouldn't be stuck like a turtle on your back if you fell on the lunar surface. You could actually roll yourself over and get back up again. That was built in. So yeah, neat little design feature there.
And then so moving on from there to stuff left on the moon. Some people, we did one a long time ago I wanted to include on whatever happened to the flags they left on the moon, because it turns out they did not specially design these things to last, which is weird. They're putting so much money and everything else. I mean, I guess the symbolic act of putting the flag there, but you'd think you'd want it would be fairly trivial to make it last, but they just picked up a normal flag you could buy anywhere to use for these things. And so it turns out, what is it, the LROC? But yeah, the Lunar Reconnaissance Orbiter camera has evidence that the flags, most of them, still there. You can see the shadows. What they look like, though, which was surprising because they thought they would just disintegrate with
UV
like
radiation.
In the sun.
Yeah,
and the UV radiation and stuff like that. But it seems like most of them are still there. And the Apollo 11 one, of course, got blasted, off. So that one, whether it's there or not, or covered or whatever. But yeah, let's see here. Yeah, but they're bleached by the sun. It's thought it would be, but it seems like they're all still there, which is another thing. You talk about every time we do a video like this, everyone's like, oh, we never landed on the moon. And that's become a more prevalent thing. It's actually becoming more people believe it now than before. And it just yes, if you don't know a lot of stuff about this or that, or some of the science, and you just look at one tiny little thing and be like, that's suspicious. But if you just step back, and you're like, the preponderance of evidence and just the massive amount of conspiracy, it's like, so the people who say oh, everyone who worked on it, they didn't know, because you can only have a small percentage of people, a very few. No, but then if everyone below them is working on the actual thing, these are very smart scientists and engineers, they're designing the thing to do it, and they believe that they're doing it. So there's so many things like that just, you did a phenomenal video on that. I think it's like a 40 or 50 minute video that we published on how do we know we actually landed on the moon? And it's just it's so ridiculous because there's so many things, and even like this, we can see the shadows.
And basically it boils down to, it would be cheaper and easier to go to the moon in the late 1960s, early 1970s than it would have been to fake all of that.
Yeah,
just given the state, you look at the state of the art of visual effects at the time, with a gigantic budget, was 2001: A Space Odyssey, came out in 1968. And even then, you can tell, the lunar lander comes out and the dust is billowing because, of course, they filmed it in miniature on Earth where there is air. They could have done it in a vacuum chamber, but the length you would have to go to fake the footage and all the weird physics that are going on, you might as well just go to the moon.
Yeah, it is. There's and there was one guy who, I think it was in the 1980s, where he really kicked off. He wrote a book on it with no expertise or anything. We have a whole video on it. People should go watch it. It's really good, interesting, kind of diving into the origins of the myth, and then you jump into all the ways we can tell we landed on the moon. It's just, but yeah. In any event, moving on from there, moon first full meal was bacon, cookies, and coffee, and some peaches and a glass of grapefruit juice. But before that, Buzz Aldrin did do the first religious ceremony on the moon, where he had a little wafer bread and wine, which they were going to, broadcast that, but then because of the, in the Gemini mission they had, it was Apollo 8. It was Apollo 8.
Oh, was it
Apollo 8? They read
it was
from
Apollo
the Genesis?
8. They read from Genesis on Christmas. Yeah, they were. It was Maury O'Hare, who was like the number one atheist in the United States, sued NASA for failing to adhere to separation of church and state, and that lawsuit never went anywhere. But they were like, okay, yeah, we should tone down the religion.
Yeah. So they told him respectfully he could still do it, but they weren't going to broadcast it. And so moving on from there, there is a sort of moon. It's moon museum, but it exists on the moon apparently, complete with a dick pic, because of course a bunch of guys going up and putting art would do that. So
but not just any dick pic, Andy Warhol's dick pic.
I know, right? And yeah, so, and it's in the gold mylar foil wrapping. They put it, was it the Apollo 12? It's basically just a 19 by 13 millimeter, 6 sketches by leading American artists at the time, and who brainchild of American artist Forrest Myers. So in 1969, Myers put out a call to fellow artists for submissions for this art gallery that he wanted to do. They're going to get NASA to send it up. So we have Robert. Oh, I'm going to butcher some of these artists. They're going to be like, oh no, that's not how you pronounce it. Robert Rauschenberg drew a single minimalist line, was all. David Navrus of Black Square. Klaus Aldenberg in interpretation of Mickey Mouse, he drew. John Chamberlain, another geometric grid pattern. And Andy Warhol did a penis, which he says, he insists it's actually just his initials made in the shape of a rocket ship. But yeah, if you go and look, like, yeah, sure, right.
Yeah, right, Andy.
It's not subtle. But yeah, so they made 20 wafers of this actually. So there are some exists on Earth, but and then he tried to get NASA to put it up in there, and NASA just never really responded. So he took matters into his own hand, and he got someone from Grumman Aircraft to embed it, which was a common thing back then. I mean, you get fired if you got caught, but people would put like little pictures and stuff. They would embed it in the mylar of the lunar modules just so they could get up there. And so yeah, it would seem that even though it's not like an official thing, there was a telegram that said to him on November 12th, 1969, that said you're on A-OK, all systems go, to basically say that we got it in there. So yeah, it's the a dick pic that exists on the moon and the moon's own thing. But there was also, speaking of that, let's see, I want to fast forward because there's a funny one.
How about the fallen astronaut, right?
Oh, there's that one.
Yeah.
That one's really cool. Where's the details? I actually have that written, but by sculptor Paul von Houdenink. The 14 astronauts and cosmonauts who have died in the line of duty. They have that one up there. But there's another more funny one, and it's Playboy Playmates. So they do, which one was it?
It was Apollo 12.
Yeah, Albine. So he's going through his checklist, and then someone had put, he all of a sudden flips, and it's Cynthia Myers, Playboy Miss December of 1969, and then later is joined by Miss January, Leslie Bianchini, and Miss September, Angela Dorian, and Miss October, Reagan Wilson, on his checklist, just embedded as he's flipping. And so those pictures exist on the moon. And
you were talking before about making the flags last on the moon. Well, the Soviets actually did that. The first spacecraft to actually reach the moon was Luna 2, I believe. It had a pennant on it. It was a sphere made of metal divided into little pentagons, each with the Soviet crest on it, with a little bit of explosives in the middle. So right before it impacted, it exploded and sent these little metal pentagons with the Soviet emblem scattering all over the lunar surface. And those are probably still in really good shape. So the Soviets figured out how to, put your stamp on the moon.
Speaking of that, we're going to finally finish. I think this is the last thing for today. The story of Dennis Hope, who sold the moon basically. And he states his inspiration: I looked out the window, saw the moon, and thought, hey, there's a load of property. So he was out of work shoe salesman.
That's like the meme. It's free real estate.
Yeah, exactly. And he needed some money. He thought there's a lot of money in real estate. He didn't have any. So what could he sell? And that's why he figured the moon. So he claims, and he claims a lot of things, and his story is real funny, and he clearly has a great sense of humor about it all. But he claims he went down to the library, as you do, in 1967, or in the 1980s, and looked at the 1967 Outer Space Treaty and saw that countries cannot claim ownership of the moon, but it said nothing, in his opinion, and we'll get into that he's wrong, that individuals couldn't do it. So he claimed ownership of the moon, which he says with his local U.S. government office for claim registries, and then he claims he badgered the supervisor to just go ahead and sign off on it, which, then he wrote a letter to the UN and Russian government telling them that he now is claiming the entire moon. So did they have any objection? If they wanted to object, they should challenge him on it in court. He says none of them bothered to do that. So he officially felt that made him the owner of the moon. And he started selling off plots of lunar real estate for $20 an acre. And he claims he sold 611 million acres of land on the moon, 325 million acres on Mars, and combined 125 million acres on Venus, as well as Io and Mercury. And one of Jupiter's moons, Io and Mercury, and then Mercury. But if you do the math on that, he's definitely making some stuff up there, because he would be, the level of wealthy he would be I did the math somewhere, but I believe he would be the richest person in the world. But either way, especially because he would be the richest person in the world, because he also claims all the mineral rights and everything, and he has some estimates on like the helium on the moon and stuff like that. He's really funny. But so it's often a lot of these things, the loophole, right? So is this actually exist? And it said, if you actually read the treaty, which we do here, obviously actually look into it, you'll find it very clearly states in Article 6, the activities of a non-governmental entities in outer space, including the moon and other celestial bodies, shall require authorization and continuing supervision by the appropriate state party to the treaty. And if you look into his supposed whatever supervisor of whatever agency, it didn't really exist. And he only has a copy because he claims he lost the original, and his copy includes lots of typos, and it also it calls himself the Big Cheese. It's like the going off that with the head cheese. That's what it was. And so, yeah. But in it, and he also on his website, it does say it's a novelty gift, but then he vehemently insists that he's not saying novelty in like fake. He's saying novelty in the different definition of it. Like, where's the quote? One, he says it's just to discourage frivolous lawsuits, but it's actually valid. And he said, if you look under the true definition of novelty as being something that is unique, having the quality of being novel, a small mass-produced item, we fit exactly that. So that's his way around that. And
you are technically correct, which is the best kind of correct.
He has his whole website and his thing, and again, like I said earlier, he has a whole page on like how to detect when someone's trying to scam you and stuff, which is just hilarious. But yeah, so he claims to be have $100 trillion net worth in his own personal net worth because of his mineral rights. And that was just on land. He also says $6 quadrillion of minerals and things that he owns. So yeah, how much did he actually make of this? Who knows? But he has not seemingly been employed in anything else since 1995. So seemingly he's doing all right for himself in it.
He didn't specify which dollars. Maybe they're Zimbabwe dollars, and he has like $50.
Yeah, no, exactly. He seems to have at least he is a funny guy though. Read interviews with him, and like he definitely, he has that line of just like, he's insisting it's all real, but he does it in such a funny way that you just kind of like, that's hilarious. So yeah, that's the main episode for today. That's everything. Do you have any interesting you want to add, or?
No, that's all good. No, thank you for having me on for this video. I'm looking forward to doing more. This is a really fun format, and glad to finally be. Well, we've been working together for 4 years now, but never directly together. So this is great. Yeah, that's good. And anyone watching, just let us know what you think. Any improvements, anything different if you liked it, and everything like that. So thank you for watching. Bye.